Dear students, today I will discuss with you some important MCQ from the chapter Solution, in which we have to discuss molarity, normality, molality, mole fraction, all these things. So, first question, 5.2 mole molal aqueous solution of methyl alcohol is supplied. What is the mole fraction of methyl alcohol in the solution? So what is molal? Molal means molality. Okay, molal means molality. So 5.2 mole of the solution in 1000 gram of the solvent. So this is 5.2 molal solution. Okay, so 1000 gram of this water is how much mole? Is what mole? 1000 divided 18, because 18 is the molecular mass of water, is 18. Okay, so you will get 55.55 mole. Okay, yes. So mole fraction, now you will calculate mole fraction. Okay, so this is how we will calculate. The solute is 5.2 mole. Okay, and the solvent is 55.5 mole. Okay, then what is mole fraction? Mole fraction is equal to, you will get 5.2 divided 5.2 plus 55.55. Okay, so the answer is your 0.086. Okay, yes. Next, second question. What is the mole fraction? So choice B is the correct answer. Okay. Next, what is the mole fraction of the solute in a 1 molar aqueous solution? Oh, okay. What is the mole fraction of the solute in a 1 molar aqueous solution? So what is given? 1 molar. 1 molar given. Okay. So for 1 molar, the solute is 1. Solute is 1. Okay. And 1 molar aqueous solution means the solvent must be solvent, that is water. Aqueous means water. Solute is 1000 gram. So what is 1000 gram? How much mole? 1000 gram of water is equal to 55.5 mole. Okay, 55.5 mole. Then you calculate mole fraction. So mole fraction is equal to 1 divided 1 plus 55.55. So you will get 1 by 56.55, and the answer is, you will get this one, 0.0177. Okay, 0.0177 mole fraction. So choice B is the correct answer. Next, the density in grams per milliliter of a 3.6 molar sulfuric acid solution, that is 29% sulfuric acid by mass, will be what? The density is asked. So how to do? Question number 3. You see, question number 3, how to do? You see, molar is given, molarity 3.6. So 3.6, you have to first write the formula. 3.6 molar is how much? 29% by mass. Okay, the solute is 29. Okay, then molecular mass of sulfuric acid is 98. Then multiplied 1000 divided what? Volume of the solution. So density, we know density is equal to mass by volume. Then what is volume? Volume is equal to mass by density. So instead of writing density, then instead of writing volume, you have to write mass by density. So mass is given what? 100. That is percent is given, na? 29%. That means 100 is the your mass by density. Okay. So by calculating all these things, you will get what? Density is equal to 1.22. You will get this answer. Okay. Yes. Next question. Question number 4. Concentrated aqueous sulfuric acid is 98% sulfuric acid by mass and has a density of 1.8 grams per ml. Volume of the acid required to make 1 liter of 0.1 molar sulfuric acid solution is what? So 98% pure. So 98%, you write for 98% pure sulfuric acid, what is its molarity? You will first calculate. Okay. So how to calculate? So molarity of 98% sulfuric acid is 98%. Its mass is given. Molecular mass of sulfuric acid is 98. Multiplied 1000. This is the formula I am writing. And molality of water, okay, 98% given, na? You will write 55.5. Okay. So then what is the molarity? Molarity is these will cancel and you will get 1000 by 55.5. Okay. Then what to do? Then you will write down the next volume of the acid required to make 1 liter of this much sulfuric acid solution is what? The volume of acid required to make. So this is molar, 98% molar. So this molar, it is the formula M1 V1 is equal to M2 V2. So M1 is 1000 divided 55.5 multiplied by V1. M2 is given here 0.1. Volume to make 1 liter 1000 ml. So both side 1000 cancel. So V1 is equal to what? 55.5 multiplied 0.1. Okay, students. So you will take multiply this. You will take what? 5.55 molar. This ml. Okay, so answer A is the correct answer. Next, A is the correct answer. Next, how many grams of concentrated nitric acid solution should be used to prepare 250 ml of 2m nitric acid? The concentrated. Okay, so how many grams of concentrated nitric acid solution should be used to prepare 250 ml of 2m HNO3? The concentrated nitric acid is 70%. Okay, so how to do? Same. Question number 5, you do what? How many grams of concentrated nitric acid should be used? So molarity 2m, 2 is given, x you have to take, nitric acid is 63 multiplied 1000 divided 250 ml. Okay, so x is you will take x. How? X is your how much? 2 multiplied 63 multiplied 250 divided 4. Divided 1000. Okay, 254 and this is 2 and 31.5. So you will take x is 31.5 gram, but you have to require 70% of nitric acid. So for 100%, you have to take 31.5 gram purity. Therefore, for 70%, so how much you have to take? 31.5 multiplied 100 by 70. Okay, so you will take, it is 45 gram. Okay, so answer A is correct answer. The A is the correct answer. Next, 6.02 multiplied 10 to 20 molecules of urea are present in 100 ml of its solution. The concentration of the solution is how much? Okay, same thing you will do. You take, you take what? Question number 6. 6.023 multiplied 10 to the power 23. This is 1 mole. 10 to the power 23. This is 1 mole. Okay, so 1 mole in 1 liter is 1 molar. Okay, it is 1 m solution. So for what is given? 6.023 multiplied 10 to the power 20 is given. Okay, so 6.023 in 10 to the power 23 in 1 liter is how much? The solute is decreasing, so you will take 1 by what? 6.023, that is 10 to the power 3. Okay, this molar. Okay, so then 6.023 multiplied 10 to the power 20 molecules in 100 ml. How much? So for 1 liter, the 100 ml, the difference is 10 times. 1 liter is 10 times of 100 ml. So you will get 10 times, that is 1 by 10 to the power 3 multiplied 10. Okay, so again you will get 1 by 10 to the power 2. So your answer is B. Okay, next question. To neutralize completely 20 ml of 0.1 molar aqueous solution of phosphorus acid, the volume of 0.1 molar aqueous potassium hydroxide solution required is how much? You see how to do this. Okay, so see the formula, acidity, basicity you have to know. Okay, so acidity multiplied by volume multiplied by molarity of A, similarly B multiplied B multiplied MB. So for phosphorus acid, the replaceable hydrogen atoms is 2. So you have to write 2 multiplied V 20 ml and your molarity 0.1. Here for base you will take potassium hydroxide, so it is 1. So VB volume it is required and molarity 0.1. So both sides the molarity cancelled. Okay, and this is the volume. The volume VB is equal to your 40. So your 40 ml. Choice C is the correct answer. Next, the volume of 4N HCl, 10N HCl required to make 1 liter of 6N HCl are what? You see how to do. Question number 8. See, 4N, the volume of 4N, let the volume is X. Okay, and the normality is 4. Okay, plus the total volume is 1 liter. So for this it is 1 minus x multiplied 10 is equal to 1 liter multiplied 6. Okay, so 4x minus 10x plus 10 is equal to 6. Okay, so minus 6x is equal to 6 minus 10. So minus 6x is equal to minus 4. So x is equal to 4 by 6, that is 2 by 3. So 2 by 3 is how much? 2, 3 dot 20, 3, 6, 18. Okay, then again 2, 20, 6, 6. So you see, this is your choice. C is the correct answer. So 0.67 liter of 4N HCl and 0.33 liter of 10N HCl required. Okay. Next, a person is considered to be suffering from lead poisoning if its concentration in him is more than 10 micrograms of lead per deciliter of blood. Concentration parts per billion part is what? You see, micrograms, question number 1. Microgram is equal to 10 to the power, it is converted to the 10 to the power minus 6 gram. Okay, microgram. So 10 microgram, so 10 multiplied 10 to the minus 6 is equal to 10 to the minus 5 gram. Okay, so again it is converted into the parts per million. Okay, parts per billion. So what to do? 10 to the power 9. Okay, 10 to the power 9, and it is deciliter. It is taken as per deciliter. Deciliter means 1 by 10 liter. Okay, so 1 by 10 liter, that is 10 to the minus 1 liter. So 10 to the minus 1 liter is nothing but 100 ml. Okay, so 100 ml contains 10 to the power minus 5 gram of lead. Therefore 10 to the power 9, that is billion, contains 10 to the minus 5 divide 100 multiplied 10 to the 9. So you will get 10 to the power, this is 7, and you will get 10 to the power 2. Okay, so this much amount of lead is requiring. So answer, your C is the correct answer. Okay, next, the molarity of 900 gram of water is how much? The molarity of 900 gram of water is how much? You see, 900 gram of water, question number 10. 900 gram of water is how much mole? We know 18 gram of water is 1 mole. Therefore, for 900 gram, it is 50 mole. Okay, so then what is the molarity? The molarity is, you have to calculate, molarity is equal to 900 gram. Okay, 900 gram by 18, it is molecular mass, and this is 1000 divided, again 900 gram of water is how much you will take? Okay, so 900 grams of the solvent you will take. So this is your 1000 divided by 18, so it is 55.5. Okay, this is 55.5 molar. Okay, so choice B is the correct answer. Next, which of the following is not a substitutional solid? Which of the following is not a substitutional solid? So what is substitutional solid? If the cation and anion size are same. Okay, substitutional solid is a type of solid solution where solute atoms replace or substituted for a solvent atoms within the crystal. Okay, so brass, bronze and monel metal, all these are the size of cations and anions. That means the alloys, these are the not cations and anions, these are said to be the alloys. So brass and bronze, the both sizes. What is brass? Your brass is, what is brass? Your brass is copper plus zinc, copper plus zinc. Bronze, that is copper plus tin. Monel metal is also nickel plus copper. Okay, so all these are the alloys with these sizes. Copper zinc size nearly same, copper tin size nearly same, nickel copper size nearly same. Whereas in case of iron and carbon, that is steel, okay, these sizes are not suitable, both sizes are not suitable. So it is an interstitial site. Okay, steel is an interstitial alloy, interstitial alloy, whereas these brass, bronze and monel metal, these are your substitutional solids. Okay, so which of the following is not a substitutional solid means your steel. So choice C is the correct answer. Okay students, have a good day.